Okay, let's go ahead and select our player now. What we're going to do is create what's called the object grabber script, which is going to allow us to pick up our physics object here. So let's collapse most of our components here. We don't need to see those for now. And then we'll hit the add component button, and we're going to type object grabber here. Hit new script, make sure it fills out the name field there, and then hit create and add. And of course, because we're creating a script using the add component button here, we do need to go back to assets and move that into resources, scripts, and created. So give that a second to open. There we go, move that into created. And then once you've got it inside created, we can go ahead and open that up. Oh, I don't know why it always opens the file before I click into the folder, but it is what it is. Great, so once we're in here, we can go ahead and delete our start method. We're not going to be using that. We are going to be making use of update though, so we'll keep that one. At the top here, we want to give ourselves some space, and then we're going to say public float range equals 5f, public float throw speed with a capital S is equal to 5f. We're going to say public layer mask LM. We're going to say public transform object holder, and then rigid body object rigid, and then finally bool is grabbing equals false. Next, we're going to drop down below void update here, and we're going to say void process inputs, and then open and close parentheses and our curly brackets, of course. And we're going to now do if input.get key down, and then key code dot e. So that means if we press the E key, then we want to execute the code inside our curly brackets here. We're going to say if not is grabbing. So that means if we are not currently grabbing, we will say raycast hit. So this variable is going to actually store information about the object that we are able to hit with the raycast we're about to use. And then that raycast will be called by saying if physics.raycast, and then open and close parentheses. We'll say camera.main.transform.position. So that's where we're going to be firing our ray from. And then we're going to say camera.main.transform.forward. So we're shooting a ray from where our camera's position is to the direction that it's facing. We're going to then say out hit. That's going to tell this raycast to send the information about the object we hit to that raycast hit variable. We're going to say range because that will be our pickup range, and then LM to tell it to only use objects on that physics object layer. And then we're going to say is grabbing equals true. And then we're going to say grab object hit.collider.gameObject. And we're going to get a red underline until we add that grab object method here in just a minute, so we can ignore it for now. Now we can step outside of this is grabbing conditional, and we'll say else. So if we are currently grabbing, we'll say object rigid dot constraints equals rigid body constraints dot none. So when we pick up the object, we're actually going to be applying some constraints to it, which is to say that we're going to freeze its position and rotation. Rigid bodies are the component that enables an object to be simulated by physics. So by adding rigid body constraints to it, we can prevent physics from affecting it until we set the constraints back to none. So in this case, if we press E while we're currently grabbing, we want to drop the object. So setting rigid body constraints to none is going to allow us to cause that to happen. We're also going to say object rigid.transform.parent equals null. And the reason for that is when we grab the object, and you'll see this in the grab object method, we're actually setting its parent in the hierarchy to our grab or our object holder transform. That means that wherever that object holder moves, it's going to also move our grabbed physics object here. And then finally, we're going to say is grabbing, set that equal to false. Now stepping outside of our conditional for get key down E, we're going to do if input.get mouse button down 1, so that means right click. If you remember from the grapple code and player controller, we do get mouse button down 0. That's left click. Get mouse button down 1 is right click. So we're going to say if get mouse button down 1, and then we'll say if we are grabbing, because we only want to do something if we're currently grabbing a box. we're going to say object rigid dot constraints equals rigid body constraints dot none, same as before because we are letting go of the box here. We're going to also set its parent to null. So object rigid dot transform dot parent equals null. But this time what we're going to do is say object rigid dot add force. And then we're going to say camera dot main dot transform dot forward. So we want to add force in the direction we're facing, and we're going to multiply it by our throw speed. So that transform.forward vector is always has a magnitude of 1, or the vector length is always going to be equal to 1. So if we multiply that by throw speed, that means that our overall velocity is going to have a magnitude equal to the throw speed that we've defined with our throw speed variable. And then finally, after that, we're going to say is grabbing equals false. And then down here, outside of process inputs, we're going to add our grab object method finally. So we're going to say void grab object, and then we're going to say in the parentheses game object to grab. So that's an argument. That's what that's called, an argument in our method. It's basically us defining what type of information this method can receive, and when it receives it, we're going to be able to use that information to in this case grab the object in question. So now we can say object rigid is equal to object to grab dot get component rigid body, open and close parentheses there, and then our semicolon, and then we say object to grab dot transform dot position, or I'm sorry, object to grab dot transform dot parent equals object holder, and then object to grab dot transform dot local position is equal to vector3.0. So what this is going to do is our local position is defined by our current parent. So an object that has no parent, local position will be the same as just saying normal position. But if an object has a parent, like we in this case just set the object's parent to our object holder, setting its local position to 0 means we're going to set it to the same position as the parent. So in this case, assigning local position to 0 means that our object is going to be sitting right on top of our object holder transform. And then finally, we're going to say object rigid dot constraints equals to rigid body constraints dot freeze all. So we don't want this thing to drop or be affected by gravity or rotate while we're moving it around. We want it to basically be sitting perfectly still inside our object holder when we grab it. Finally, the last thing we want to add is just up here in updates, we want to say process inputs, open and close parentheses, and our semicolon. Excuse me, sorry about that. So now if we go back to our Unity editor here in the test scene, and we have our physics crate here, we're going to go ahead and bump this guy over to the side a little bit, just move him closer to our player. Once we have him over here, we'll hit play. And we will walk up to this guy. And I just realized we did forget to set our layer mask, actually, so let's do that very quick. So we need to select our player. We also didn't set our object holder, so that attempt would have been doomed to fail from the start, so we can fix that very quick. With our player selected, let's actually do this on the prefab because we want this to stay consistent across scenes. So we'll go to gameplay prefabs and we'll double click on the player prefab here. And you'll notice we actually don't have our script for the object grabber here, so we can go back to our scene view, click on player, and then overrides apply all, and that will update our player prefab to have the stuff we want. So now we can click into our player prefab, and there's that object grabber script. We're going to set this layer mask to physics object, and then we're going to add an empty game object that's going to be that object holder. So we hit right click on the player and then hit create empty. Going to create an empty game object right on top of our capsule here. What we want to do is select our camera and look for that blue arrow. That blue arrow is telling us what is considered the forward direction for our player. So no matter what's in front of that blue arrow is going to be what our player sees. So we want to move our object holder in front of our main camera. So let's rename this to object holder. And then this also happens to line up with our current blue arrow, so we're just going to slide this out. We're going to want to put it a good distance in front of our player because, you know, that box is kind of big. We want to make sure it's not bumping into our player while we move around. So, you know, a Z value of something like 1.75 is probably pretty safe. And then we can go back to our player now and drop that object holder transform into our object holder field here in the object grabber script. Now, if we go back and hit play, and we can find our physics object here, and if we hit E, now we've got this guy and he follows us around. If we right click, if we press E, we'll throw it. If we right click, we'll throw it. But it looks like we don't have quite enough throw speed, so we can up that by selecting our object grabber. And let's up throw speed to like 50, because it didn't seem like it was moving much there. So we'll do that, and then grab this, and then now we can right click. And that's still pretty low. I guess for add force, we need a pretty big value, so we'll crank that up again to 500. And we should see that move pretty good here. Let's see, where is that at? Go. There we go. So yeah, something like 500 is probably a better value than 5. And now you can see we can throw this object around, or we can press E to just drop it. We're also able to jump on top of these, although we can't jump immediately. This is up to you if you'd like your player to be able to jump on the crates. I opted to leave it so that you can't, because on some levels you may want to have multiple crates, and if you could stack crates, you could end up breaking your level. But in the event that you want them to be able to do that and stack crates up and then climb up the crates, all you would need to do is go to your player controller, select our layer mask here, and include physics object. But again, I'm not going to do that just because I think it works a little better without it, but that's something that you're welcome to experiment with if you so wish. We actually want to make one change to our player prefab here. So we're going to open up our player script, and you're going to notice that we have our object holder here as a child of player. We actually want to make that a child of our main camera. And the reason for that is if our player looks up, we want the box to move up with them as well. And you might notice in the next couple videos that that doesn't happen for me. I actually realized I forgot to do that, so I went back and fixed that for you guys. So when you play, you should see it look like this, where you look up and then the crate moves up with you. So if you notice that doesn't happen in the videos, don't worry, that was just a mistake on my part. But you can look up, and that will actually make it feel a bit better when you want to look up and throw the box up in the air like that.